Today we have more rinky dinky chinky products to look at, and this came in the post. It is they say it is a converter. And it's only worth £2.33. Right, okay, well, whoop. As you can see, I've already opened the box. And what have we got inside? Well, we have a little box of probes. And I bet I can't get this open. This is genuine, first time, never seen this before, as you can tell. Yeah. God, you need arms like King Kong to get that out of there. So, a box of probes. A funny thing, look at that, SKU. The writing on that looks almost identical to the Malachite SDR that I looked at yesterday. Hang on a minute. Well, there's the Malachite SDR, and there's the probe. They both got SKU numbers. They both got writing almost identical. Isn't that strange? I wonder if these were designed to go with other products made by this company. I wonder who the company is that makes these things. I know, because they're sold by lots and lots of different sellers who obviously don't know what they're selling. But these are made by somebody. It's the same box as the Nano VNA comes in. This little plastic box. And it's got all these lovely probes. I'll get the box out of the way because it's reflecting light like mad. I've got these little probes. These two are different. You've got dinky, mid-range. No, hang on. You've got 3 different sizes on those. Those would be the current probes. And then you've got these, which look like voltage probes. I think this is a high frequency one, that's a lower frequency one. I can't remember how much the kit was. It wasn't too expensive. This is cheap Chinese stuff compared to the really expensive products, but you know, if they do the job, that's going to be good enough for me. It's all PCB. It beats making your own, to be honest. If you were going to make your own, you'd have to get a SMA connector, like some cable, and you'd have to cut the cable, put a loop in it, insulate it. Oh, it's a load of faff. So just buy them. These are quite cheap. It'll come with the nice little nipples on. Nice little nipple protectors. So I'm going to have a play with these in a minute and see what they perform like. Well, I struggle to find anything noisy enough to demonstrate this. All my devices seem to be relatively compliant. One or two things like my computer and my computer power supply were a bit rough, but I can't get the camera anywhere near to them with enough light to show you what's going on. So, what thing most likely to cause interference? You've guessed it, a Chinese power supply. Just had to be Chinese, didn't it? Not that I've got anything against the Chinese. They make some wonderful low-cost products. Anyway, let's turn this thing on. See what effect it has. Oh look, nasty sprogs. down this bottom end. It's not good having sprogs down your bottom end, I tell you. Oh, my camera work is awful. You know, one day I'll learn to be a proper videographer. Here's the probe. As you can see, there's nothing when I take it away. And as I bring it closer to the offending device, up come the sprogs. Quite a lot of them. This is a scan from 50 meg to 350 meg. And there's a lot of stuff down the bottom end. 50 odd megs. I don't know what this region is. I haven't played. As you can see, it's quite noisy. Now probe various places on the device. See, that end isn't as noisy as that end. This end's really hot. It gets less hot as you go down there. Oh, the lighting's playing up. One thing also to note, I can't get this power supply very close. It's got a short cable on it, so it's difficult to get it any distance away from the mains plug. And I can't get my camera close to the mains plug, so we're up the creek without a paddling device. Anyway, just to show you that there is muck on that mains cable. Lots of muck. So they haven't done a very good job of suppressing that, have they? Anything on the output cable? And the answer is yes. Loads of it. Loads of muck on the output cable. And around about 39 megs, I think that says. 38, 39 megs is that peak down there. And I don't know what this one is. Probably twice that. So we should be able to find that on a receiver. Now I've set the X7 here for 39 megs. This seems to be a sort of broadband interference. It's all over the place, so I can't find a particular carrier frequency. But here's what happens when you get the probe. As you can see, we pick up a little bit on the cable at that end. The hot spot seems to be there. That's the hottest spot. Not so bad there. And there's muck on the output cable as well. Sorry about the focus problems. This is the slightly smaller probe. I think this one probably has multiple turns. If I can get it to show. Come on, focus. Or is this? No, I think it has a single turn. Okay, this one. Yes, single turn loop. And the ground plane on the other side. It how does this one perform? Well, it detects the noise on the cable. And it goes up. It goes bananas there. Change the volume, the voltage. Horrible noises. I find it better when, for wideband noise sources, to use the AM mode on the radio. FM is better for looking at single carriers. It's to detect changes in the quietening level of a carrier than it is to detect changes in the volume of a weak signal. So use AM mode for wideband noise and FM mode for carriers. And as this is putting out wideband noise, that's why I'm using AM. I don't know whether you can actually hear the noise, but I've changed to the little tiny probe now, and this allows you to get in really close. Say you were doing fault finding, find out where the actual source of the noise was coming from on the printed circuit board. This would be the ideal one for the job, because it allows you to look very precisely. See, there's nothing coming off the display, but you go along here and there's your noise source. It's there. It's not just here. It's the, it's. You can locate it very accurately with this. Now, as a test, let's just take the probe off the radio and stick an antenna on it. I can't find a way to stop this thing auto-focusing, which is a real pain in the neck. But this is with the rig itself. You see, with the rig, you can tell it's noisy. But you can't tell where the noise is coming from. So they make life much better. With the radio, I can't really tell if that cable is radiating, or whether it's the power supply that's radiating, or whether it's that cable that's radiating. But this is great because you can say, oh yes, that cable's radiating. There's a noise source in there somewhere, and there's a noise coming out of that cable. It's just so simple with these things. Anyway, I've enough, so you get the idea. You can use these with a radio, or with a tiny SA, or a Malekith SDR, or whatever you want to use. And this is bye.